Okay, now before answering these questions, I'd recommend printing out this image so that you can use a ruler to draw all over it. That's going to be far easier than trying to work it out on the computer screen. So part A says, where is the image formed? The exact answer, if you want to give a distance from the mirror, is going to depend on what scale you print it out at. But let's answer that for here. Where is the image formed? So what we're going to need to do is do some ray tracing. So let's use green for the rays, and we draw a couple of rays. The first one, we can draw one which is parallel to the principal axis. Okay, so let's draw the first one parallel to the principal axis. And now what we want it to do is, when it's reflected from this mirror, it's reflected through a line which goes through the focal point. So with this software, I can try and get my line all lined up as best as I can. So there we go, that's going through the focal point, and then once it goes through the focal point, it travels away from the mirror like that. So it's traveling this way, but then the eye doesn't interpret it as traveling that way, it interprets it as coming back from here. Okay, now we need to draw another ray. We draw a ray coming from the object, which would go through the focal point. So we just need to adjust our line to get that as close as we can. That looks pretty close. Okay, so the ray comes along here. Now at this point, it will be reflected from the mirror back parallel to the principal axis. But so let's draw that now. Okay, that looks fairly parallel. So it's coming this way, but the eye interprets it as coming from back here. Okay, so this here we've got the rays coming this way, and this is where they are interpreted as coming from. And so this here is our image. So part A asked us where the image was. Now if you have a ruler, you can give the exact length there. Because it's going to vary from person to person depending on what scale you printed it out at, I won't give that answer. But where is it formed? So it's formed behind the mirror. You could ask students this in a test with a printed diagram, and they'd all get the same answer because it had all been printed at the same scale. Now B, is it real or virtual? Okay, it's real if the light rays actually travel through that point, but this is behind the mirror. The light isn't actually going there. So this tells us that this is a virtual image. And then part C, what is the magnification of the image? So the magnification is equal to the image height over the object height. Okay, so you're actually going to need to get out your ruler and measure that. So when I did that, I got that my image was 3.5 millimeters tall and my object was 11 meters tall. So solving that, I got a magnification of 0.32. Now you could get slightly different numbers here for the image and the object height depending on what scale you printed it out at, but the magnification should be very close to this. There's a little bit of uncertainty because we're using the ruler, so you can't measure 3.5 millimeters too precisely, but you should have roughly the same answer as that. Now, part D asks, if the object was twice as far from the mirror, what would be the answer to these questions? Okay, so now the object is moved back somewhere along here. Now, if we consider this first ray, which is traveling parallel to the principal axis and is then reflected off the mirror, that's identical for these two objects. But the second ray, where we're going from the object, from the top of the object, roughly here, it's a good idea to draw it more precisely than I have, and through the focus. So if we draw that one, let's draw it red so that we know it's a different object. Once this gets to the mirror here, it will be reflected back parallel to the principal axis because it's going through the focus. So this will be reflected back. It will actually travel along this way, parallel to the principal axis, and the image will be where these two cross. And so our image in this case is here, and so it's behind the mirror again, but it's slightly further behind the mirror, so you could measure the exact how much further it is. So we'll put it's further behind the mirror. It's still a virtual image because the light is still not actually passing through there. And then with the magnification, you can see that the object hasn't changed. So the object height's still the same, but the image height is smaller. So we would expect a smaller number. Now, when I actually measured that, I ended up with 2/11, which is equal to 0.18 for the magnification. Your magnification would be somewhere around here as well. Okay, so that's how we solve that problem.